Buffering. Beep boop, beep boop. This is for the outtakes. Welcome to the Death Star in Space podcast. I'd like to introduce our first guest, Rose. Go right ahead.
Hi, everyone. I'm Rosie, and Blaze is awesome. Can't wait to see you guys put your own things in space one day.
As Rose says, my name is Blaze. Used to work at NASA and just really want to send something cool up into space. So the Death Star in Space is basically what it sounds like, a 10 centimeter Death Star with a laser that we're going to shoot while it's up in space above 100 kilometers. The Kickstarter will be launching this year, April 11th on Yuri's night, the same day the first human went into space. So it's just going to be a space-filled fun day for everyone. And like I said, we're doing this because it's awesome and it's fun and I like Star Wars. So I'd love for students or people of any age to learn a little bit about how to write code and have some fun with us. You can get more details at www.deathstarinspace.com. So Rosie, why don't you tell us a little bit about why we decided to do this podcast in this way?
In order for us to be able to actually end up getting to Mars, I think there's a whole lot more of us that need to learn a whole lot more of the skills that it'll take to get there. Blaze and I are both big fans of empowering people through education. And since Blaze is open sourcing the whole entire project, we thought we'd go through step by step and teach you guys not just how to launch something in space, but how to put together some of your own circuits and use some of the open source tools. So all you guys at home can build your own and be able to do more above and beyond this. So eventually the hope is that you guys will be able to get instructions through my augmented reality glasses. But in the meantime, you have to listen to this podcast.
Yeah, that's a great point. You don't have to be a lover of Star Wars to take something away from this. You can use this to build anything you could think of, to make your toaster automated, to dressing dolls with a robot, to, I don't know, anything you can think of. Use the same code that we're open sourcing to make your own thing.
It sounds pretty awesome, but let's not jump too far ahead because that sounds a little crazy to me already.
True. So what we did was beforehand, we set up and downloaded some code before starting the podcast. So on GitHub, it's a great website. It has pretty much all the world's open source code for people to check out, submit to improve. So it's a really great resource if you're starting a project. So before this podcast started, we had Rose go download the Death Star in Space code from GitHub, which is a great website for open source projects. You can go there and check out code from around the world from probably millions of people, I would guess. And so what Rose did was go to our GitHub repo, which is at github.com/open source Ironman /Death Star in Space. And there she was able to download all of our code. So Rosie, I guess what were the next steps?
Yeah, so Blaze, once we've downloaded the code, did you want to show us how to open the files or go through what a .spin file is and each of the different what is Python or spin code and how are we going to use them?
Yeah, sure. So after you've downloaded the code, you should have a folder called Death Star in Space. And if you click on those and navigate down, you'll see two folders, one called Python _code and one called spin _code. So those are two different types of code. Python is a scripting language and spin is a language for programming microcontrollers, and that is what's inside of the Death Star. It's a small microcontroller from Parallax, and it's really good for doing really low level stuff like controlling sensors, IMUs, and doing all of that with really low power versus, say, the Raspberry Pi, which would draw more power, and you would normally write the code in something like Python. And so that's what that Python folder is for. There's a bunch of code in there that runs on a Raspberry Pi that lets you kind of mess around with the Death Star in a different fashion if you don't have our open source Death Star hardware to mess around with. So you can use Python in a Raspberry Pi instead. So what we're going to focus on today, though, is the spin code section. So if you navigate down into that spin code folder, you should see, I think, like 10 or so different spin files, and they end in .spin. And like I mentioned, these are all for programming the Parallax microcontroller. And so what we're focusing on today is the spin dash, sorry. And what we're focusing on today is the stem dash code dot spin file. And that's where code will be written that will actually fly on the Death Star as it goes into space. And it's a place for students around the world to write their own code. And it's a starting point with a bunch of examples for how you would control a Death Star and how you would do things like measure temperature, pressure, and altitude with a sensor on board, and how you would also flash LEDs and do a bunch of cool stuff on the Death Star. So that's what we're going to look at today and go through line by line. So if you click on that stem dash code file, Rosie, it should open up inside the Parallax IDE. Is that correct?
I'm not seeing a stem dash whatever file. I have the propeller IDE open, but I'm not seeing the stem file.
There you go. Cool. You got it.
Yeah, it wasn't showing up at all before. Okay.
Maybe because it was open before you downloaded the file. It's a bug in the code. That's interesting.
Interesting.
So now that we've downloaded the stem.code file and opened it inside of the Propeller IDE, we're going to take a look at this. It's 171 lines of code, and it was written by myself as a template for students to use to write their own programs. And so as we walk through it, ask any questions that are confusing, Rosie, or give input on how you would change things. That's probably the most important bit, because we want people to be able to write their own stuff.
Cool.
So let's start at the top. The first 19 lines are documentation, which I find super. Go ahead.
So when you say documentation, does that mean that it's just text and it's not anything? We can change it, make it say whatever it's supposed to be, or like we can change it, make it say whatever we want. Sorry.
Yeah, the first 19 lines are just describing what this file does for people and how they should use it. So this is not something students should change, but it is important because it tells people what the purpose of it is, how they can contact me if they have questions. It also tells when it was written on Christmas Eve of last year, actually. And so documentation is super important for any project. When you start writing your own code, you should start writing documentation first so that you understand what you're doing, and then actually start writing real code, because otherwise it can get very confusing, I think, anyway. And it's easier for you to share your code with other people and have them help you if you write comments and documentation about what it's supposed to do before you start writing code. So
cool. So the top part is just comments?
Yes, exactly. Yep. First 19 lines are just comments.
Cool.
And then we get into the variable section. These are 3 variables here that will be used, as the code is running, and these three variables can change. So that means during the operation of the program, information will be written into these memory locations. And does that kind of make sense?
Not really, but I'll stick with you.
All right. And then, so I guess variables, to put it a more simple way, are human words that are translated into memory locations inside the computer. So as the program runs, it'll save information in these locations. So they can be ever changing, and it's just easier for humans to read, and so that's why we give them names, so we can call them back later on. And then from line 31 to 39, there is a constant section. And so these are values that never change at all, unlike variables during the operation of the code. And so we just have useful things like a high always means 1 and a low always means 0. And then for the clock frequency stuff, this just means that the crystal is 5 megahertz, and we're multiplying that by 16 so that our propeller microcontroller runs at 80 megahertz, which is really fast for a microcontroller. And that's why I like the parallax ones so much. They're a lot of fun and they're really fast.
And this is like totally outer space to me. So I was an optical engineer in school and we made lasers with crystals. And so, but I think this is different. There's one time I did make a lightsaber that like actually worked, but
What? That's
um,
awesome.
explain this crystal frequency and the PLL multiplier, or is that something we just might be easier to understand once we put the hardware together?
Easier once the hardware is put together. It's not super important. That actually won't change. That's why it's in the constant section. So there's a crystal on the hardware that vibrates at 5 megahertz. And so the microcontroller uses that to create a clock inside of it that runs a lot faster at 80 megahertz. And that's how it knows what it's doing and how it times everything to happen at the same time. But it's not super important to know and how the code actually operates.
Cool. Sounds awesome.
Yeah. And then the next section is objects, line 42 to 59. And so these are other bits of code that I've written, like the word clock, the word tricolor LED, and the MPL 3115A2. This is all other code that I've already written that students will never have to look at, but they can use it in this stem-code.spin file to do cool stuff with LEDs or with temperature and pressure sensors. So this object section is just a way of describing code that's already been written for you.
Okay. Do you wanna take me through maybe why the debug file? Like, I mean, I know we're building hardware, but are we supposed to have like a mouse trap in there as well?
Not that would be cool. There's some code that actually does stuff like that. But in this sense, debug is used to like print error messages to the window. So that's the one way you can debug your code if it's not working the way you like. You can use this debug object and print things like my code got here, or the current value of um, variable is data saving equals false. So just a way of testing what's going on.
Cool. And then if we wanted to like have our LED blink to like Funktown, would we change the the pattern in that file? Is that possible?
So you don't have to touch any of these files, like the tricolor LED file. I've already written that, and so to do cool things with the LED file, all you have to type and do is type LED dot something, and we'll take a look at that a little farther down in the code and how you do cool stuff with the LEDs without having to look at the file.
And the lasers?
And the lasers and the altimeter. Yep.
Cool.
So next is Lines 61 through 75, it's the main function. So that's where code operation starts. So when you boot up your program, it starts at the main line and actually starts running on line 63. So here we're just setting up the clock. Again, it's not super important, but it's basically setting it to 80 megahertz with those two lines of code. And then debug.start, that is starting our debug terminal for the Parallax serial terminal. And that'll just be a window that pops up so that you can figure out what your code is doing. But the most important bit are the next three lines of code. You see is data saving is a variable that we created up above in the VAR section. And we're going to set that to false, at least initially as our program runs, and we'll use that in different ways. Like for example, in line 72, we're actually not going to have the altimeter data save, but we're just going to print it to the screen instead. And line 70, just above that, is a simple LED example program, which is the main focus for this first episode and for this podcast.
So if you're doing this, and someone asks how high you are, you really can't tell them?
You can tell them exactly how high you are to the meter.
Cool.
Lines 88 through 96 are all documentation. They tell you what this part of the code, this function does. And so what I wrote, because I am a super nerd, is I wanted to print out Star Wars quotes and then turn on the correct color LED so that it matches the lightsaber color of the character. I thought that would be cool, and it is cool. What do you think, Rose? Is that cool?
It couldn't be more cool.
Awesome. So, starting on line 99, these are the objects that I mentioned above, the timing dot things and the debug dot. So what the first line of code does is just pauses for a second and gives the propeller a chance to stabilize and slow down so that it can print the text out correctly as we go through the text. So it's important sometimes when the Parallax first boots up to just pause for a second so that everything will run normally. Just like when your computer boots up, it's a little slow and weird in the beginning, and if you just wait, it's the better way to go.
Cool. Great tip.
Next line of code where it starts getting juicy is line 101. So again, like I mentioned, the object files that we looked up above, like debug. So in order to send a debug message to the terminal, you simply type debug.send text, and then the word string here turns your words that follow it into strings, and strings are just letters that you can print out. So it's just the format that you have to follow in order to send text. So it's always send text, parentheses, string, parentheses, and then the thing you want to send in quotes. And again, I just pause after printing out my name, just so that it's easier to read. Because sometimes if you print out too much text to your debug window, it gets really hard to understand what's going on. So it's always nice to pause in between prints to your debug screen.
Cool. And that's what you have on line 102 and 106 and 109 and so on.
Yep, exactly. And you can do different lengths if you want to pause 5 seconds in between, so you can take your time to read. You just replace the number 2 with the number 5.
Is there a way that you can pause until a button is clicked?
Yes, there is. I don't show that in this example program, but it's relatively straightforward.
Cool.
Cool. So next is line 104. So if you can guess what this quote is from, without looking at the comment at the end of the line of code, then you're awesome. So basically, it prints, "You are on the council, but we do not grant you the rank of master," to the
What?
debug screen. So this is what Mace Windu said to Anakin Skywalker in, I believe, episode 3. Um, and that made Anakin very mad because he was awesome, but they wouldn't let him be on the council. But he was a master, so that was one reason he turned into a bad guy, because the Jedi are stupid. I probably should take that out of the podcast. Anyway, so Mace Windu says this, and so I wanted to turn on the LED and turn on the purple LED. So our LEDs are actually tricolor LEDs. So they only output red, green, and blue. But if you go to our website and to our blog, you'll see a picture. So if you type in that URL, Rosie, into your browser, you should get a blog entry, and it will show the LED that we use on our board. It's open source, so we put it on our website. And in order to create purple, you actually have to combine two different colors together.
Yellow and orange.
Red and blue works.
And does that SMLP36, does that mean anything, or is that just the computer spitting out a random name?
No, that's the part number for the LED that we have inside the Death Star.
Cool. Why did you choose this LED? How do you choose an LED?
We chose this LED because it's super, super small and it has 3 colors. We wanted to be able to do a bunch of different cool things. So it's an all-in-one package. It's nice and small, lightweight. It just makes it easy.
So by your screen, it looks like you're combining red and green to make purple, or
Yep.
blue and green. Is that right?
Red and blue will make this like a kind of like magenta, pinkish purple.
That's what
I
that
call
means.
it purple.
Gotcha. It's confusing.
Yep. So in our code that we wrote for students inside of the tricolor LED.spin file, we did all of the math and the code control to generate the purple. So in order for you to use it in your sample program, you just need to go to led.turn-on-purple, and that will make you have a purple LED.
Will you show us that?
And then the first number inside these parentheses is the duration, and the second is, this is actually a number. It's the frequency that the LED flashes at. And so for this example, this number actually equals 772 or 772 hertz.
And where do you change that if you wanted to change it?
So if you wanted to flash the LED at 2 hertz, which the human eye could see, you would, instead of having this constant variable, you could just type the number 2, and that would make the purple LED turn on for 5 seconds and flash at a frequency of 2 hertz.
Cool. And what is hertz again for all those who have not yet gone through their physics classes?
So hertz is cycles per second. So how many times a wave goes up and down in a second. So with 2 hertz, a wave would go up, down, twice in that 1 second. Yeah, twice in that 1 second. So every half second, the LED would turn on, then for a half second it would turn off, then for a half second it would turn on, and so forth.
Cool. Thanks for that great explanation.
No problem. And then again, on line 106, I just pause for 2 seconds so that we can enjoy the purpleness and so that we can read the quote as we go along. So basically, do this 4 more times for different color LEDs. In episode 6, Luke Skywalker says, "I am a Jedi like my father before me." But before that, he does an epic pause where he has his lightsaber on. So I turn on the green lightsaber, which is the color of his lightsaber, during episode 6. He started with his father's blue one, but built his own green one in episode 6. So he turns on his lightsaber, uh, and then I pause dramatically for 3 seconds here, and then he turns off his green lightsaber and says that quote. Um, and so that's how you would reenact that scene in the movie in code. And for this
Well,
example, I actually turn on the lightsaber for an infinite amount of time instead of just 5 seconds.
so then how do you turn it off?
So that's why, unlike with sorry. So that's why, unlike Mace Windu above, um, you turn it on and then you turn it on for 5 seconds. This one has both a turn on and turn off green. So it's turned on infinitely. You pause for 3 seconds and then you turn it off. You don't actually have to turn off Mace Windu's lightsaber because after that 5 seconds, it will automatically turn itself off.
Oh,
So yeah, every time you call turn on a color, it turns off the previous color that was turned on. So you never have to think about it. Just makes it easier.
cool.
Cool. And so line 114 is a Darth Vader quote, the epic, "No, I am your father." And so I turn on his red lightsaber right after he says that and pause for 2 seconds. And then next is Anakin Skywalker with his blue lightsaber. This is a quote from episode 2 when he's talking with Padme on the beach. A lot of people make fun of this quote because it's kind of weird, but he doesn't like sand. It's coarse and rough and irritating, and it gets everywhere. And so um, I then turn on his blue lightsaber. And then finally, probably the least known character in line 121. Again, this is actually from the Clone Wars animated cartoon. Ahsoka Tano is an awesome, powerful female Jedi. She's like the best Jedi ever. Like people absolutely love her. Like she's amazing. Yeah, she's the best. And so she is actually a Jedi that's kind of in the middle. She's not like Darth Vader and super evil, and she's not like Luke Skywalker, the perfect good guy. She uses both sides and is just a really good person because of it. So she mixes the good and the bad and is considered a gray Jedi for that reason.
Too cool. It's great to have females to look up to.
Hopefully she comes back in some of the new movies. She's an awesome character. People like her a lot more than Rey. So she's super cool.
We'll have to check her out.
So she says this to Anakin Skywalker as she walks away from the Jedi Council. She says, "Sorry, Master, but I'm not coming back," as she turns her back on Anakin Skywalker, and everyone cries, and it's a beautiful scene. So in this example, I actually use a variable. That's what line 122 is, the on time variable. So instead of typing the number 5 over and over, if you want to turn on a purple lightsaber for 5 seconds, you can just have a variable that you set one time. And for this example, it's 42 seconds. So then when she turns on her awesome white lightsaber, you call LED.turnOnWhite, and then you send the on time variable there for the first position before the comma, and it makes the white LED / white lightsaber stay on for 42 seconds.
Cool, cool beans.
And yeah, and then the end. So that is an example of how you would use the debug screen to send text as you're debugging your code, or to send funny quotes. And then in order to control the LEDs, you simply call the colors that you want to use as you're going through your program.
I can't wait to see it in action.
Gonna be cool. Any other major questions or concerns?
I just want to know how to plug it in and light up my lightsaber.
So for that, you'll be using a little USB adapter that plugs into a 4-pin header on the Death Star.
Maybe it's time for a good next episode or another episode.
Absolutely. Yeah. So this is Blaze.
This is Rosie.
And we're teaching you how to send your code into space on a Death Star. You can check out the website at www.deathstarinspace.com. Thanks. Come back for episode 2.
What did the GitHub repo say to the engineer?
Why'd you push me?
I am your master.
Not bad, not bad. I'll take it. I got it right away, so that's good.